Okay, so in these problems we're looking at more examples of inequalities. When you're solving for x in an inequality, do everything as you would when you're balancing equations, except if you find yourself multiplying or dividing by negative values, switch the direction of the sign. So we're going to switch direction, right, of this sign right here. So if it's facing the left and it's opening to the left, you switch the direction and open it to the right when multiplying or dividing by a negative value. And what I'll say about that, just imagine if you have 3 greater than 2. This is true, but if you multiply both sides by negative 2, you get negative 6 and negative 4. Which one's greater now? Well, now negative 4 is greater, right? So we switch that direction. The idea is that you took a positive value, which is further from 0, and when you multiply by a negative value, it's still further from 0, but now it's less. The 2 is closer to 0 and less in the positives, but in the negatives, when it's closer to 0, right, it's higher in value. Think about a number line, 3, 2, 1, 0, negative 1, negative 2, negative 3. Here's negative 2, negative 3, negative 1, 0, 1, 2, 3. Okay, so here in this case, if I start with 2 versus 3, right, and I multiply by negative 1, 2 becomes negative 2. Oops. Sorry. 2 becomes negative 2 here, right? And that's negative 2. And 3 becomes negative 3. So 3 travels to distance further from 0, but that makes it more negative. 2 travels to a distance that's closer to 0. And to begin with, that means it's less. But then when you get into negatives, that closer to 0 distance means it has a higher value. So keep that in mind when you're solving these. And here with negative 6x minus 17 greater than or equal to 8x plus 25, decide what side do you want your variables to go on. I'm going to choose the right-hand side because I know that this negative 6x, if I add it, right, that'll give me a positive value to work with. And then if I subtract 25 on both sides, I'll bring my numbers to the left. These cancel out. What is 8x and 6x? That's 14x. Negative 17 minus 25 is like 17 plus 25, except negative. So that's negative 42, right? And it's greater than or equal to 14. Divide both sides by 14, and x is less than or equal to negative 3, right? So here we're looking for a value, x is less than or equal to negative 3, which is choice number 4. It's just written in the reverse order. Okay. This question is asking you, where is the solution for these two lines? Well, these two lines, right? This line right here is dotted, and it's shaded this way. You can see these shade lines here. So all these shade lines represent y values greater than some mx plus b line, right? So it's dotted here, the line itself, because we don't include y values that are on the line, just line values that are greater than. The other line, however, the line is shaded in, right? It's not a dotted pattern there. They color the whole line in. This is also greater than as well, but this is going to be y is greater than or equal to some mx plus b value. And in this region here, right, if you look at this region, kind of color it in, the two lines are crossing, right? That's the solution set for both. So they're asking you which point is in this shaded region. That's it. The first point is negative 2, negative 1. So negative 2, negative 1. It's here on the intersection. I wouldn't count it in the region, especially since you can't include points on this line. If you could include points on this line and it was shaded in, this point would be okay. Negative 2, 2. So negative 1, negative 2, and up to this point is clearly in the region. Let's look at the others. Negative 2, negative 4. It's down here. Nope, that's not in the shaded region. And 2, negative 2, 1, 2, is only in one of the shaded regions, but not both. Here we're asked to graph these two inequalities. So we'll do this by hand, and I'll just show on the graphing calculator how this works. First thing I would do is set up my axes here. So I'll get my y-axis and x-axis. Okay. And then let's graph the first one. Y is greater than negative x plus 2. Think of mx plus b. The plus 2 here is the y-intercept. So we have plus 2, right? 1, 2. And then negative x, that means the slope is -1, or you can think of that as -1/1. This number up here refers to the delta y. This number here refers to delta x, or changes in y and change in x. So if I'm standing here at 2, I can go down 1/1, right? Down y, down 1 on the y-axis, up 1 on the x, and so forth, right? Down 1/1. So we get this line right here, except the line, we're told that y is greater than than negative x plus 2, not equal to. So we draw a dotted line through these points. Sorry, you would have a ruler there, and you would shade the region above it. So this is the one region we're looking at here. The other region, y is less than or equal to 2/3 x plus 5. Well, again, plus 5, 2, 3, 4, 5. Here's your y-intercept. And 2/3, well, your slope is 2/3, so that means you go up 2/3, right? Or you can think of it as down 2, back 3. Down 2, back 3. Oops, back 3. Okay, so, get that right? Yep. So y is less than or equal to. So now we shade this line in, because it's less than or equal to. So we can include the line, and we're shading below this region here, right? Everything below it. Okay. And label the solution set S. Well, the solution set S is where these two lines cross. So you wouldn't be coloring it in. I'm going to color it in for you because I have color available. But what you could do is just write in this region, say, oh, this is the solution set S. On a graphing calculator, you can do this pretty quickly as well if you're feeling overwhelmed by graphing whatever line you're given. Just click your y equals button here, and I already set it up so it's in the correct mode, but you can scroll over to the left and toggle through these different graph options by pressing enter. And what you might notice is as you toggle, there's scatter plots and different things and lines, but here this blinking region is shading above the line for the upper triangle, and then if I click it again, it goes below the line for less than or equal to. So I don't think we can do less than. In other words, I don't think we can dot the line versus shading it in. I could be wrong on that. But this is what we have to work with. So this will be the less than 2/3 x plus 5. So in parentheses, 2/3, 2/3, x button plus 5, and the second, it's greater than, oops, okay, y is greater than negative x plus 2. Enter. So if we graph these two, you'll see, right, you can zoom in the shaded region as well. It's good practice in the graphing calculator. Okay, Chelsea has $45 to spend on the fair. So she has $45, and this is a common kind of problem. So we know right now whatever she spends can't exceed this. It has to be, let's say, less than or equal to that. She spends $20 on admission and $15 on snacks. So that's $35. And each game is 65 cents. So she can play G for games, 65 cents per game. Write an inequality to find the maximum number of times she can play the game. So this is it. Because 0.65 times the number of games plus the $35 spent has to be less than less than or equal to the $45 she has to spend. Now they ask us to solve. So that's a pretty common second step here. So 45 is greater than or equal to the $35 she spent on admission and snacks plus 65 cents per game. So I'm going to subtract the money spent already. That will tell me how much is left. So subtract 35 from both sides. And that's $10 is greater than or equal to 0.65 G. So here, right, we can do 10 divided by 0.65. And here, that means G has to be less than or equal to 15.38. So how many games is that? What's the maximum number of times? We can't play 0.38 of a game, so the answer would be 15, right? Okay. Solve the following systems of inequalities graphically on the axes below. Alright, so here I'm going to just subtract 3x so on both sides, so it says y is less than 7 minus 3x. I prefer to work in y equals mx plus b format. First thing I'm going to do is draw my axes here, my y and x axes. So here's my y, here's my x. Okay. So they tell us here, this first line is 7 minus 3x. 7 is your y-intercept, so 1, 2, 3, 4, 5, 6, 7. Cool, I fit. All right, negative 3x, so that means negative 3 is your slope. M equals negative 3. So that means our change, our rise is negative 3, 1, 2, 3 for every 1, right? And here y is less than this, so we draw a dotted line, not a solid line, because we don't include where y equals the x, 7 minus 3x, it's below it, so we just shade below. The other line, y is greater than or equal to 2/3 x minus 4. So minus 4, that's our y-intercept, negative 1, negative 2, 3, 4. Slope is 2/3, right? So we go up 2 over 3, up 2 over 3, and so forth. Okay, this time we can shade in the line because it's greater than or equal to. So, oops, draw the line right through it. Oh boy. There we go. Okay, it's better. And it's greater than this time, so we shade in everything greater. State a coordinate of the point in the solution set. So they just want, the solution set is where these two regions cross each other, which is right in here, right? This region as well. So if we pick any point in here, we're good to go. So I'll pick, let's say, this point. Or this point, even better, 0, 0. So 0, 0 is in both. And you can test that. If you plug in 0, 0 to these inequalities for x and y, they will be true. You know that you've got the wrong point. Let's say if I pick this point over here, 1, 2, 3, 4, 5, 6, 7. 7, negative 1 is not a solution, because if you try to plug in 7 for x and negative 1 for y, this inequality will not be true. I'll show you one example. In the first one, if you plug in 7 for x, you get 3 times 7 plus y, y is negative 1. Is that less than 7? 3 times 7, 21. Plus negative 1, what's that? Well, 21 plus negative 1 is 20. And that's not less than 7, right? That's not true. So this point is not in that inequality. And you want to plug it into both, right? If you think, like if I pick the point here, it would work for one inequality, but not the other. It's in the blue region, but not the red. So just be careful. You can plug these points in. You can do this on a graphing calculator. I have other videos on that. Okay, Jason's part-time job pays him $155 per week. So we have $155 for every week that he works. He already has $375. What is the minimum number of weeks he needs to work to have enough money to buy a dirt bike for $900? So this actually, we want to know how many weeks does he work so that the total amount of money he has is greater than or equal to the $900 he needs. Preferably greater than, because you don't want to spend all of your money on the bike. I mean, you have to eat and do other things. So we just solve for W, right? Subtract 375 from both sides, and then we're going to divide by 155. This cancels out. 900 minus 300 is 600, minus 75 is 525. And now we have 155W. Divide everything by 155, and we'll have our answer. So 525 divided by 155, that's 3.38. So about 3.38. W has to be greater than about 3.38. So what's your answer then? Well, you can't work 0.38 of a week, so you've got to finish that week, right? So that means you've got to work 4 weeks in total to get the $900 needed. All right. Length of a rectangle is 15. Width is W. Okay. And the perimeter is at most 50, so less than or equal to 50. Which inequality can be used to find the longest possible width? So on a rectangle, of course, you have length, width, and width. So if we add 2 lengths plus 2 widths, it has to be less than or equal to the perimeter of 50. So we could use that one. But 2 lengths we know is, every length is 15, right? So plug that in, and 2 lengths becomes 30. So 30 plus 2 widths have to be less than or equal to the perimeter that they're giving us, which is choice number 2. So, it's less than or equal to because at most 50. Less than means it can't be 50, but we can use 50 here. A correct translation of 6 less than twice the value of x is, so 6 less than means 6 subtracted from something. So it's 6 less than 2x, right? Which is choice 4. All right, here they want us to graph these two. I'm just going to rewrite them. So instead of y plus x is greater than or equal to 3, subtract x from both sides and get y is greater than or equal to 3 minus x. Right? If we subtract x from the left side, x cancels out. Subtract it from the right side, we get minus x. Same thing here, it's a little bit more complicated in the second one. We subtract 5x from both sides, cancels out. Negative 2y is greater than 10 minus 5x. And then the last step is divide everything by negative 2. Except that'll reverse the sign. So we get y is less than negative 5, right? 10 divided by negative 2 is negative 5, plus 5 halves, because negative 5 divided by negative 2 is a positive. So here, once I have that set up, I prefer to work in mx plus b format, or slope-intercept format. I set up my y and my x-axis. And I quickly sketch these out because in one of them, right, we have 3 minus x. That means 3 is your intercept, 1, 2, 3, and minus x is your slope. So we go down 1 over 1. So here y is greater than or equal to this. That means we draw our line, shade it in because the line itself is included. Okay, rough sketch there. And y is greater than or equal to it, so we shade everything above it. Okay, the next thing is y is less than this other line. And the other line is just, it says negative 5 plus 5 halves. So negative 5 is the y-intercept. 1, 2, 3, 4, 5, negative 5. Right? 1, 2, 3. Okay. That's your y-intercept. And the slope is plus 5 over 2 or plus 2.5. But I won't think it is 5 over 2 because that means you go up 5, 1, 2, 3, 4, 5, and over 2. Up 5, 1, 2, 3, 4, 5, and over 2. And this time y is less than that. So I'm going to dot the line because it can't be a point on this line, only below it. Right? So here we shade in this region. Below. And what they ask us next is state the coordinates of one point that satisfies the first inequality but does not satisfy the second. All that means is pick a point that satisfies the first, and the first is this red, right? This red. Greater than, right? Y is greater than. So a point that's in the red region but not in the blue region. That's all they're asking us. So I'm going to pick the point right here. This point's right on the y-axis. It's easy to spot. So it's 0, 1, 2, 3, 4. But you can pick any point in the red region that's not in the blue. And don't mess with points really close to the line. Otherwise, you have to plug them in to your inequality to test them. All right. Which graph represents y is greater than 3? Well, lines that say y is greater than 3 is a horizontal line, and it's choice 1. The line is dotted because it's not greater than or equal to. That would be this one right here. Y is greater than or equal to 3. These lines, if you remember, these are x is greater than or equal to 3, and this is x is greater than 3. Just, you don't have to memorize that. Just remember that, if y is greater than 3 and that's your equation, that means y is always greater than 3. So this line right here is where y equals 3. It's just a line where every point has a y value of 3, right? Like 3, 3, 4, 3, 5, 3, negative 1, 3, and so forth. All the points have y values equal to 3. Same thing here, right? Here, all the points in this line have x values equal to 3. Here, same thing, right? So you don't have to memorize that. Just look at the points in the line and you remember, is it y equals 3 or x equals 3? Look at the point values. Okay, Mr. Stanton asked his students to write an algebraic expression on a piece of paper. He chose 4 students to go to the board and write these expressions. Which one wrote an expression? Well, expression does not have an equal sign, so these are out, and does not have a greater than or less than sign, so only Meredith wrote an expression. That's all there is to it. An expression does not have an equal sign or an inequality sign. Solve algebraically. Well, here we could distribute the 2 and the 1/2, but if we multiply everything by 2, let's look at what happens. If we multiply everything by 2, I think it's nice that you kind of save some steps and get rid of a fraction. So multiply everything by 2. And what's going to happen is this term, right, is going to become 4 times x minus 4. Remember, it's 2 times this, and if you're multiplying 2 times something already, when you double it, you just get 4 groups of that something. Greater than or equal to 1 times 5 minus 3x, because 2 times 1/2 is 1. Now, you don't need to distribute the 1. So let me clear this off. 1 is the identity and does not need to be distributed. But we should distribute this 4, get 4x minus 16, greater than or equal to 5 minus 3x. We add 3x to both sides because I want to avoid negatives, right? If I subtracted the 4x to the right, I would get a negative value. And I'm going to add 16 to both sides. What happens? These cancel out. 16 and 5 is 21. And then we get 4x and 3x is 7x. And then we can always solve, right? We have 7x greater than or equal to 21. Divide everything by 7. X is greater than or equal to 3. Our answer. The only thing to think about that's different when you balance inequalities versus equations is if you find yourself multiplying or dividing by a negative, you must switch the direction of the sign. Okay, if 5 times a number, 5x, is less than 55, what is the greatest possible integer value of the number? We'll just solve for x. Divide both sides by 5, and x is less than 11. So you can't pick 11 or 12. It has to be less than 11. And then with the greatest possible integer, remember integers are whole numbers, positive or negative whole numbers, including 0. So here 10 is the greatest integer, less than 11. All right, thanks.